Gonna have so many different, all right, so let's look at this one.
Yeah, let's look.
All right, so let's look. So slope of the tangent line, we know we need dy dx, and we're going to plug in this 0.20. So we're going to start going across. Is x squared a basic? Yes, so 2x. Is y a basic?
Sort of.
Sort of, right. So the derivative of y with respect to x, we just write
Right over
dy
here.
dx. Okay.
Oh, okay. Oh, yeah.
Right, right. 4e to the y, is that a basic? No, because it's not an x. So it's a chain rule, e to the something, what's the something? Y.
Y.
So 4e to the something goes to 4e to the something times the derivative of the
dy.
something, dy dx.
Okay, so dy dx, is that up in the exponent or does it come
No,
down?
so this is on the line. So y is in the exponent, but dy dx is, so we have the derivative of the outside function times the derivative of the inside function.
Okay.
All right, so now let's look. We're trying to solve for dy dx, so we need to get all the dy dx's on one side and everything else on the other. I like positive numbers, so I'm
We all
going to
like
take
positive
this one
numbers.
and put it over here. I know we like to solve for things on the left, but I much prefer to have all my things be positive. So I'm going to say 2x equals 4e to the y. And again, I'm going to go with the y prime just because I just find it's fewer variables. And you can go straight to y prime. You don't even have to write dy dx. You can go straight to y prime if you want to. I'm just going to tell you that when we do related rates next week, we will be back to this, it won't be dy, it'll be dt's, but just to bear in mind that we can do it either way. Plus y prime.
Can you like since you're adding that y prime to that, you could do like 2y prime or something?
No, because so let's talk about that. So importantly, I'm going to write a line under this to show you how I've written it on the page to make sure that you get everything lined up right. E to the y is the exponent, y primes are not. So now, what do I have on this side? I've got a y prime common to everything. I've got 4e to the y of them, plus another one of them. That's one way to think about it. I've got this many plus that many more. Because it's a 4e to the y, I can't say 4 plus 1 is 5 because it's not just 4. So I'm going to have 4e to the y plus 1. And again, make sure that you've got everything correct in its elevation. So now, what do I need to do to solve for y prime?
So,
Take this, yeah, just divide both sides. So I'm going to now put my y prime on the left. Is everyone okay with that? I'm just dividing both sides by this, switching sides. So be very careful as you're writing to make sure your exponents stay exponents. So this is my derivative. Have I answered the question?
No.
No, I need to evaluate it at 2, 0. It's just a very quick, we're going to use this notation when we get to integrals. This is just a very easy way to write what we're doing. So now we just plug in 2 times 2. Do not be afraid of exponentials. Most of the time it comes out really nice, like 4e to the 0. Anything to the 0 is 1. Anything to the 0 is 1. So we get 4 over 4 plus 1, 4/5. Okay, here's another interesting question I'm going to ask you. Can I ask you this?
No.
I'm not going to. Yes?
So you brought down the equal sign on the 4 to the 5th, so it would still be y prime there, or would
Yes, this would be y prime. Yes, so this would be y prime evaluated at this. So yes, let's be a little bit more careful about that. Thank you. So this is y prime. That's a general formula for y prime. Y prime evaluated at 2, 0.
Okay.
That's a much better way to write it, is 4/5. Yes, thank you. Part of the reason I harp on that is because keeping your notation correct will help you move through the problem correctly. When we start getting sloppy either with our writing or with our order or with our labeling, it's easy to get the wrong pieces in the wrong places. So just being a little bit more systematic. Okay, any other questions I can answer on this one? All right, let's look at another one. All right. let's do this one. So again, slope of the tangent line. At 3, 1. And your equation is 3x squared plus y squared squared equals 100 xy. So let's talk about how to identify. Yes. Okay. Let's talk about how to identify what to do, and then I'm going to turn you loose to give it a go. Okay. So as I'm reading across, let's start with this side. What rule do I need to use on this side? Product rule. This is x times y. So product rule on this side. So we're going to have a first and a second. What do we do on this side?
Product rule and chain rule?
Not product rule, but chain rule, sort of, yes, I've got something squared, so this is my inside, so it's a chain rule. And then within the chain rule, I'm going to have two separate pieces that I have to deal with separately. Yeah. Okay, so this side should be pretty straightforward. This side, you're going to do something squared, so the something stays, and then you have to do the derivative of the something, the derivative of the inside. So give that a go, and then we'll talk. Yes. Start with the right hand side. That's easier.
Yeah, I understand how to do it, I just don't know how to apply it.
When you're doing this,
That's the thing is, I do understand how, I just don't understand, it's like, I don't understand how to apply it.
is dy over dx.
It's not a plus.
Oh.
It's not a correction.
Okay, but how far if you have a base and it's even x?
That's not the base. This is a multiplied.
Okay, but e doesn't exist. E is just saying that it's exponent.
No. E is a number, 2.7.
What? Oh, so that's len. Or-
Yes, that's the same base as a limb. So that
Okay,
E,
oh, okay, so
this
you're
is not
saying,
what I'm going to count.
you're actually saying 4 len
No,
to
no.
the line?
I'm saying 4 either one. So 4 times.
I feel like you must have skipped this whole e thing from Greek out. I don't remember this.
Yes, E is about 2.7.
I just keep seeing this e number and I'm like,
Yeah,
what is
it-
going on, man?
Just remember that E is kind of like pi. And
Yes.
how we're using it in here, we don't actually break it down and actually use the number.
Right, we just
kind
leave
of
it
move
E.
around.
Right, we just leave it E like we leave it pi. Yeah, so, but so on a calculator, that's an
When you
interesting
did, like,
point.
when you did the power rule the other time, it just, I don't know, it felt like you were doing it different than you were doing it before. Because like last time, I thought it was like, you had like 20 e to the x. The derivative was like,
20
E to the
no,
x times
20
20.
to the x is different than 20 e to the x.
I feel like, yeah.
Yeah, 20 to the x, that's the base. So when we talk about the base, 20 to the x, the base is 20.
Yeah, I get that.
E to the x, but so if I write this, the base is e.
Okay.
20 is just a number multiplied out front, like 20x squared, 20 square root of x, 20 e to the x, 20 ln x. So the e is the base, the 20 is the number in the front, the coefficient.
Okay, I'm
Yeah.
getting it now.
Okay, very good.
I'm there with you.
Okay,
I just clearly memorized something that wasn't right.
yes, and I'd love to correct those things.
I
So,
was like, because then you brought it up with y's, and I was like,
All right.
wait,
Okay.
what did you do with the 4?
all right, so let's start working through this because we're running short on time.
And you have 3 minutes.
Yeah, I know. So let's knock it out in 3 minutes. So, and this is where, like I said, if we, in the new way that we're going to move to, the easy ones we did in the beginning, you would have done at home, you would have done some practice one at homes, and then we would have come and spent the entire time on these hard ones. So I think that's going to be a better solution. So let's look at this. Let's do this
When are we gonna start doing that?
after test 2.
Okay.
Because I need to have a good stopping point to start it. So we're going to start right after test 2. Yeah, so in a couple weeks. Okay, so let's look at this one. This is a chain rule. 3 times something squared. So the derivative is 3 times, that's the something squared part, right? That's the power rule, so I drop the something back in. Now I need to do the derivative of the something. I'm a big fan of brackets. You know, if you just start a big bracket. Derivative of x squared, is that a basic? Yes, 2x. Derivative of y squared, is that a basic?
Mm-mm.
No. X squared is the basic, Y squared is not. It's still 2Y and then derivative of the inside. Yeah. So now is this side complete?
Yes.
Yes, because I've handled the outside and I've handled the inside. So now I come over here. This one's different. This one's a product rule. The 100 just stays out front. So if you want to, you can start with 100, another big bracket. Just know that you're going to multiply everything by 100. Or you can consider 100x to be the whole first function. That's an absolute. Would you rather do it that way?
Yeah.
Okay, all right. So we'll make this the whole first, 100x. So the first, 100x, times derivative of the second. Derivative of y with respect to x is
Y prime
dy dx, or y prime. Plus the second, y,
times 100.
times the derivative of the first, 100. Yeah. Okay. So now what do we need to do? Oof. We got to find, so when do you multiply out and when do you not? The only time you multiply out is when you're going to have to regroup like terms. I see a y prime in here separate from this other piece. I'm going to have to multiply this out in order to get this as a separate piece. So the only time you multiply out is when you need to get to a separate piece. Otherwise, leave it in factors. So, I'm just going to, so this is, so let's just start multiplying. So I'm going to take this piece right here and multiply it by the 2x. So 3 times 2 times 2, 12. What comes next? Powers. What comes next? Polynomials. So coefficient, power, polynomial. That's the order we're going to write it in just because it's cleaner. And now I need to do it again. I'm going to take this one and multiply it by this whole second term. So again, 3 times 2 times 2, 12. That's a polynomial. Here's a number. I'm going to write the power first, then the polynomial, and I'm going to write that y prime at the end. I like to write the y prime at the end because that way I know it's at the end. It's easy to find because that's what I'm going to start grouping. And then over here, 100xy prime plus 100y. We go okay so far?
There's no way I can do it by my thing and like not accidentally write an 11 instead of 12. So
I know, and that this is a, so on a test, I'm not going to give you one like this.
Thank God.
To sharpen your algebra skills on this one though, you need to do the hard ones. It's just like any athletics, right? If you're going to swim a 50-meter race, you're going to swim a 100-meter race, 200-meter race. You're Michael Phelps. Are you only going to do 200-meter practices? Are you going to do 6,000-meter practices, 20,000-meter practices, right? If you're Michael Phelps, you're not just going to swim once back across the pool and go, okay, I'm done, I'm ready. No, you're going to do hard stuff so that when it comes to the test time, the short ones are a walk in the park, okay? So I want you to really, so yes, there's a lot of algebra in this one. So just
So
to
are we
sketch out,
finished here?
we're not finished here. So just to sketch out, we're going to take the two y prime terms and get them on one side and put everything else on the other side. And then we're going to do the final division. So anyone who wants to stay and hear that, fine. Otherwise, you're dismissed. Anyone else who needs to? No one's getting up. Okay. All right, so let's go then. 12y. So I'm putting the 2y prime. I'm going to write kind of fast. There's that one, and there's this one. And they both have a y. Can I? All right. Y prime there.
she's like,
All right, so I got all
like terms.
the y primes on one side, everything else on the other. So 100y minus this whole first term. So you don't have to copy me. Copy your first term. 12x squared. A y prime factors out of all of this. What did I do wrong?
No, I'm just trying to follow. I'm
Okay.
just trying to follow.
So now I'm going to pull. Does everyone see so
Both terms have like.
they both have a y prime in it. So the y prime is going to be that whole right-hand side. Everyone know that abbreviation? RHS, right-hand side, left-hand side. Divided by everything that's part of on this side. So 12y x squared plus y squared minus 100x.
Right, but you should be able to get rid of x squared plus y squared because the top is going to be 12x parentheses x squared.
No, they will not cancel.
Oh, because of the minus one.
That minus and the plus handcuffed together. You can't separate. You can't cancel only a piece.
Right hand side.
Here, so that's right-hand
I see,
side,
I see,
otherwise
I see.
known as this.
I glanced, all right.
Yes. So importantly, you can't cancel, I'm still seeing this some in the homework, you can't cancel those two pieces because that's one piece together. Yes,
So if the 100Y wasn't on top and the 100X wasn't on the bottom, it'd be different, right?
yes, if that's what you have, then you can cancel because they're multiplied. Plus and minus is what handcuffs. Multiply you can pull apart, plus and minus handcuffs.
So then to finish that, we would just plug in
And then
the
to finish
numbers.
this, yes, plug in the numbers. That's your
Right.
final answer, yes.
So like, couldn't you then take that and then turn it into two, like you gave, like you created two fractions? Where they both have the same denominator, then you could
There's no,
cancel.
no. Because if I pull
Oh,
this
because
apart
of the
into two
minus one
fractions,
X.
the bottom stays the same, right? You can't pull,
You
you
did
can
have minus one
pull
X.
apart numerators, denominators are stuck.
So is, that's on the